6.5 is function operations. Okay, we're going to be talking about functions. So things listed as f of x, g of x, h of x. Okay, what you're seeing on the screen here. And we're going to just basically between today and tomorrow go through a whole bunch of different operations. We're going to start today with how do we add f and g, how do we subtract, how do we multiply, how do we divide, okay? And just a little bit of the pieces that go with that. And then probably tomorrow, depending on timing, we will talk about how to compose functions. So how do we make it f of g of x or g of f of x, or I don't know if you remember talking about fog in the past, f composed with g of x. Not the fog outside, but in the classroom. So just everything that we can to work with functions. Those are the pieces we're going to go through. Now, good news for starting basic, okay? Add and subtract. And so, given two functions. So in our first example, we have f of x defined to be 3x plus 4, and g of x defined to be x squared minus 5x plus 2. Keep in mind, f and g will change each problem, but that's what they're defined to be in this case. They're asking us to perform each function operation and then find the domain. So in example A, we're asked to find what is f of x plus g of x. Folks, don't put too much effort into this, okay? I said we're starting off easy today, right? What is f of x defined to be? F of x is 3x plus 4. Then we're being asked to add g of x. What's g of x defined to be? X squared minus 5x plus 2. What do you guys think we do? Huh? Yeah, combine like terms, right? All you're looking at doing here is just what can we add? Okay, so when we combine like terms, what do you see?
3 minus 5.
Okay, we can put 3x with minus 5x, which is going to be 3 minus 5, negative 2x. What else? Okay, there's a plus 4 and a plus 2 that go together. And 4 plus 2 is going to make it 6. And then what can we not forget?
X squared.
There's an x squared. So when I write this, I'm going to write, tend to go highest power to lowest power. So I'm going to put x squared minus 2x plus 6. That's all you're asked to do for f of g, or f plus g. Now, we can't forget, they did ask us to cover domain. Okay, now, domain on these isn't going to be too bad. Think in terms of f, first of all. F of x is 3x plus 4. Are there any numbers that I can't put in place of x right here? Okay, and when I ask that, it's kind of a tough question right now because you're not really sure what I'm referring to, but basically, like, if this was a fraction, we would say, well, we can't put 0 in the denominator. Or if this was a square root, we'd say we can't put a negative under the square root. But 3x plus 4, are there any numbers you can't multiply by 3? No, you can multiply any number you want by 3. So in terms of f, we can put any number in we want. Are there any issues of g? No. Anytime it's just things like x's, x squareds, things like that, you can put any number you need to in, okay, or want to in. So, in this scenario, my domain for f plus g is just going to be, if anything can go in, all real numbers. Okay, they're going to ask you some domain questions in homework, but if it's just things like adding like terms and stuff, think all real numbers, okay? When you have to not think about all real numbers is when we're going to talk about fractions or square roots, But in this scenario, all real numbers. Easy enough? Okay, part B of this is f minus g. Okay, so similar to part A, except that we are subtracting. So I'm going to write this out as f, which is 3x plus 4, and then it's going to be minus. Now, because I'm subtracting g, for right now I'm going to put g, the whole g in parentheses, so minus the quantity, x squared minus 5x plus 2. And I'm just doing that. Why did I put that all in parentheses? Everything in g has to be subtracted, right? Okay, it all has to be subtracted. So, and you could just go ahead and put like terms together, or I'm going to write this without the parentheses, that we have 3x plus 4. It's going to become, if you're subtracting x squared, it's going to become minus x squared. If you're subtracting negative 5x, it's going to become plus 5x. And if you're subtracting positive 2, it's going to become minus 2. Okay? Not that you have to do this rewrite step out I just did. But now put your like terms together. What do we have? What do you think I'm going to start off with?
Negative x squared.
I'm going to put that highest power first. So there's a negative x squared.
Plus
What?
8x.
3x and 5x is plus 8x.
2 minus 2. Plus, well, yeah.
Plus 4 minus 2 becomes a positive 2. So we end up with negative x squared plus 8x plus 2. What about the domain? Didn't we kind of already talk about it? F was already all real numbers. G was already all real numbers. Put them together, it's still all real numbers. So again, domain, all real numbers. Okay. You'll notice in example A that I just did, these were listed as f of x plus g of x and f of x minus g of x. That's one way they might ask you to add or subtract. Now, in example B down here, we have a new f of x. We have a new g of x. Okay? Notice they ask us a little differently. It's f plus g of x. But guess what? Am I doing anything different? No. Okay? That's just a different way for them to express it. No big deal there. It's still asking us to do f plus g. So let me write it out. My new f is 2x squared plus 7x minus 1 plus my new g is 3 minus 2x. And what are we going to do again? Add like terms, yes? What do we see here? I'm going to put my 2x squared out front. There just happens to only be one x squared term again. What do you want in x's?
5.
7x minus 2x is a plus 5x and
Negative positive 2.
minus 1 plus 3 is positive 2. Thoughts on the domain? All real numbers. I don't have any fractions. I don't have any square roots. I'm just putting numbers into x's and x squareds. So any number can go in there. So my domain, again, is indeed all real numbers. Okay. On B, they flipped it, and we're subtracting, yes? Do pay attention. With adding, it doesn't really matter what you add first. With subtracting, it matters, right? So do pay attention. So G minus F. So I'm going to start with G, which is 3 minus 2x minus F. I'm not saying you have to. I'm writing in a set of parentheses to begin with. So minus the amount, 2x squared plus 7x minus 1. Okay? If you feel a desire to go straight to your answer, go for it. Otherwise, I will do a rewrite step. So it's still 3 minus 2x. If I kind of basically distribute the minus sign, it becomes minus 2x squared minus 7x, and minus negative 1 is plus 1. Again, you don't have to write that stuff out. Okay, that's a personal choice. Clean it up. What do we have here? If we start with the x squared term, it's just a negative 2x squared again. What do we have in the way of x's? Negative 2x minus 7x is minus 9x. And 3 plus 1 is plus 4. Okay. You got the basics of adding and subtracting? Okay, look for the like terms. Oh, what did I forget on this one? Domain. What do you think about the domain? All real numbers. Again, it's going to be fractions and square roots that are going to throw us off. Because fractions, the denominator can't equal 0. Square root, we can't have a negative underneath it. But unless you have anything like that, where you can't plug certain numbers in, otherwise it's just going to be all real numbers. Okay? Okay. What? I threw a word problem in the middle of the front page? I didn't save it for the end? She's getting picky here. Okay. Yes, I did throw 2 word problems in. Okay? Now, in reality, what it is our multiplying section. Now, I don't know if it's good news or it's bad news, but I'll tell you up front. You have a word problem just like A in your homework. But bad news, it's a word problem in homework. But I've got to do it. Good news, it's just like example A that we're getting ready to go through. Okay? So follow the same steps when you get to homework is what I'm saying. Okay, so this second midsection, we're talking about multiplying functions. Now, I don't know if you guys caught it. There is a little formula up here that is important. Okay? And it is the fact that revenue is equal to price times demand. Okay? Revenue being, you own a store or something, revenue is what you are earning, right? What the money you're making, essentially. Okay, after you cover all your costs and stuff. And it's equal to the price of something times the demand for that item. Okay? Now, let's read through A. Step 1 of a word problem. Read it. Okay? The demand D in units sold for a company's new brand of cell phone at price X in dollars is given as D of X equals 5,000 minus 10X. What is the company's expected revenue from cell phone sales in terms of the price X? Then state the domain of this function. And if the price is 200, how much revenue will the company earn? Okay. This is actually kind of like a 3-part question. Good news, bad news there, okay? Let's go back through and reread. Okay? Look for some information here. The demand D, so they're telling us that D is demand, right? Yeah. In units sold for a company's brand new cell phone at price X. So a couple of key things. D stands for demand. X stands for price. In dollars, okay? good to know there, is given as d of x equals 5,000 minus 10x. So they gave us a formula here. What did they give us a formula for? D, which is demand. Okay, so there is an equation for demand. Now, first question. What is the company's expected revenue from cell phone sales in terms of the price X? They're asking me for what? The revenue. Okay. How do we find revenue? Price times demand. Okay. What did they say? What did we already talk about price is in this problem?
X.
Price is X. What is demand? D, or 5,000 minus 10x. Okay, so let's try and find our revenue. Now, for revenue, I'm going to call revenue R, obviously, and I'm going to call it R of X, which is what you could expect to see. Okay. So R of X is equal to, revenue is equal to price. What do we say price is? X. Times demand. What do we say demand is? 5,000 minus 10x. Yes? So you've just written the equation. Now, if I had to guess, they're going to want you to do one step here before they enter your answer in Savas. I'll be honest, when I was playing around with the homework, making sure I had the problems I wanted taken out of there, I went ahead and did the next step, which is to what? What can we do with that X out front? Distribute. Do you have to distribute? I honestly don't know. Would they let you put your answer in like this? Maybe. But I'm going to go ahead and distribute. If you distribute X, X times 5,000 is 5,000X minus X times 10 is 10X squared. Okay, guys. There's your first answer. Got it? Now, okay, next piece. I'll be honest, this is the trickiest piece. Then state the domain of this function. Okay? Now, as we talk about domain, in terms of plugging numbers in, are there any numbers you can't plug in there? Not exact. I mean, any type of number could go in there because you're just multiplying, adding, subtracting numbers. But this is a word problem. So we have to take into consideration the scenario. Okay? Let's talk about price and let's talk about demand. Let's talk about price first. Think logically. The price of an object has to be what type of number?
Decimal. That was.
Does it have to be, could it be just any real number?
It has to be positive.
Does the price have to be positive? Yes, right? You've never walked into a store and them saying, oh, this is negative $5. Let me give you $5 to take it with you, right? That doesn't happen. Okay, so in terms of price, we said price is X, yes? So X has to be positive. I can say that something is positive by writing it as greater than or equal to 0. which technically that means the price could be 0.
It's free.
That's free. I guess technically free is a thing, right? I'm just going with how, they did use equal to in the notes. So, okay, so that's part of this. Okay. Well, the other part, so that was price. We also need to talk about demand. Okay. So we talked about price. And we're going to talk about demand. And then we're going to put them together. Okay, as I said, I was honest. This is the hardest part of this problem. But you're going to see the same thing in homework. Demand. Demand is the want for a product, right? If you're developing a product, there has to be demand for it, right? If there's no demand for a product, are you going to be able to sell it? Probably not, right? There has to be a demand. Okay? With that in mind, you can't have a negative demand. Demand has to be positive. So we had a demand formula, yes? Our demand formula was 5,000 minus 10x. That demand, just like the price, has to be positive. So it has to be greater than or equal to 0. Now, as I said, we're going to want to put these together. We're going to solve this for x first. How do I solve 5,000 minus 10x greater than or equal to 0 for x? Eventually. Let's get the x by itself first. How do you want to get x by itself? Okay. He says add 10x over, yes? What's the other option? Could you subtract the 5,000 over? There's pros and cons both ways here, yes? Okay. I'm going to go with the subtract 5,000 because I want to remind you of a piece of information. It's not that I'm not liking the add 10x, okay? But I have my reasons here. So if I subtract the 5,000 over, basic solving, 5,000s cancel, negative 10x greater than or equal to 0 minus 5,000 is negative 5,000. How do I get x by itself? Divide by what? Negative 10. This is why I did this, because there's a catch here. Negative 10x divided by negative 10 is x. Negative 5,000 divided by negative 10 is positive. Negative divided by negative is a positive. 5,000 divided by 10, cancel a 0, and it's 500. Now, okay, guys, it's been a minute since we've done this. What happens when you divide by a negative in an inequality situation? It does. Does that sound familiar at all? Yeah. Okay, so greater than or equal to becomes less than or equal to. And why was that? Because we divided by that negative there. Now, if I would have taken Braden's way and I would have added the 10x, I wouldn't have had a negative to divide by, right? But what I would have had is I would have ended up with x on this side, 500 on this side. So I would have ended up with the same thing of x less than or equal to 500. It just would have been reversed. Okay. Now, we have to put this together, guys. Overall, our domain, what do we know? Two things. One, x has to be greater than or equal to 0. What's the other piece I know? X has to be less than or equal to 500. So what's it have to be between? 0 and 500. In order to write that, I'm going to put x in the middle, 0 on the left, 500 on the right, and they're both less than or equal to signs. So 0, less than or equal to x, less than or equal to 500. Probably just went through the toughest part in homework. I don't know, maybe not the toughest, but a tough part in homework, okay?
So do you not do anything with 200? And the price is 200.
We still have part 3 to do.
Oh,
There's still a third part to this. Sorry, I was not seeing the 200 at that exact moment. I'm like rescanning the problem. I couldn't. That's next. Okay? And notice, we did what is the company's expected revenue. I did that in blue. Then state the domain. I did that in red. Now, if the price is $200, what variable is price?
X.
X. So this is saying if X is $200, how much revenue will the company earn? Revenue. This is the easiest part of the problem, I promise. Revenue. Do I have a formula?
Yeah.
Yes, we just came up with it, yes? And now I have a number for X. What do you think I do?
200 times.
We're going to plug it into our revenue. So X equals $200. And we're going to plug it in. So I'm going to do R of 200. So I'm finding the revenue at $200. Now, we don't do anything with R of 200. That's just what we're finding. Plug it in. 5,000 times what? 200 minus 10 times what? 200 squared.
That's a lot.
You can do it. Do the math. Might want a calculator out, I guess. What? 5 times 2 is 10 with 5 zeros after. That's like 1 million. Minus 200 times 200. So 2 times 2 is 4. And then you're going to have 1, 2, 3, 4 zeros there. Times 10 puts a 5th zero. So I think that's going to be 400,000. What's a million minus 400,000? 600,000. When the price is 200.
Oh, yeah.
Okay. Okay. I hope you followed along. I hope you wrote down details, because this will definitely help you do a problem in homework. Okay? Questions I should answer here. And obviously you could have used a calculator on this last one. Most of you didn't have calculators out, so I just went with it. It was doable. Some of you would argue with me, but it's doable without a calculator. Okay. I threw another word problem in. Even though certain people didn't like that, I threw another word problem in. Now, I don't know if it's easier or harder, but there's only one part to it. Okay? So let's look at B. Suppose demand D for a company's product at cost X is predicted by the function D of X equals. And the price P that the money can charge for the product is given by P of X equals. Find the company's revenue function. Okay, guys. Again, they told us that demand is D. At a cost X, they gave us a function for D of X, which is demand. And they told us price is P. And they gave us a function for P of X. Okay, guys, remind me, how do we find revenue? Okay. Revenue is price times demand. I probably should not have used a multiplication X there. Okay. Revenue is price times demand. So, for revenue again, I'm going to use R of X. Price. What's price? Not just X.
Oh, P of X is that
P of X, which is
X plus
X plus 16. Okay? Times demand.
You're at 6.
Well, that would make a difference here in a moment, wouldn't it? Sorry. Did I say 16 though?
Yeah.
Okay. I don't know. X plus 16 for price. What about demand?
negative 0.25 X squared plus 1,000.
Don't miss the 1,000 over there, right? Okay, so demand. Negative 0.25 X squared plus 1,000. Sorry, I should have reformatted that so it ended up all on the same line, but
I was like plus.
plus, it's over there. Okay, guys, there's your revenue function. Now, what do you think we should probably do? We should distribute. Technically, this is a distribute, or you could say FOIL. Okay, it's not bad though. Let's FOIL. What's first? X times negative 0.25 X squared. What happens when you multiply X onto that?
X to the third.
It becomes X to the third. So negative 0.25 X to the third. Okay, now X times 1,000. 1,000X. So plus, bless you, 1,000X. Now, 16 times negative 0.25 X squared.
Something X squared.
Negative 4 X squared. And 16 times 1,000? 16,000. Okay. The way mine worked out, it's not in order, but is there anything I can add?
I don't think so.
I have an X to the third, I have an X squared, I have an X, I have a number. You could reorder this. You could probably just type it in this way. Okay? Which, in all honesty, I don't know that you have one exactly like this in homework, so. Okay? Okay, guys. That was technically all about multiplying, but I threw in our word problems there too.
That one was easier than the first one.
Huh?
The second one was easier than the first one.
I know. I told you it would be. Okay. We've added, we've subtracted, we've multiplied. Ready to do a little division?
Need a brain break.
Well,
A brain break?
let's see what, I don't know how much of this division we'll get through, but let's look at it. Okay. I'm looking at the end of class time here. But the basics here are going to be similar to what we've been doing all period. They give us an f of x. Let f of x equal x minus 7. They give us g of x. G of x is 2x squared minus 13x minus 7. Perform the function operation f over g of x, and then find the domain. What are they wanting us to do here? F divided by g. Now, It's not as, some of you I think are anticipating actual horrible division. No. Basically, they're asking us to look at f of x over g of x. What's that mean we put on top? F of x, which is x minus 7. What's it mean we put on bottom?
2x minus 36.
Okay. Now, the division part will only happen if there's any factoring that can be done. Okay? If something can factor and we have something that can cancel, then that's when we would divide, because we would cancel those factors. Kind of like what we did in that chapter right before Christmas. We were factoring the top, factoring the bottom, and canceling the factors in common, right? I know, that's December. You guys don't remember much, but you need to. Factoring and canceling. Now, as it is right now, x minus 7, does that factor? It does not. The only thing you could think about is a GCF, but there's not even a GCF. Okay? The denominator. And I'll be honest, if the denominator doesn't factor, we're done. There's nothing we can do. However, I'm going to tell you right now, this is one of those answers you'd put it into Savas and you'd get the, while this is equivalent to the correct answer, it is not in simplified form. Okay. In the denominator, GCF is a good check. There's no GCF. Folks, this does factor into 2 parentheses. Now, what's the catch though? It's 2x squared instead of x squared. Well, you can't just put out front because it's not a GCF. So, slip inside is what I would say. Now, I will say, I don't have time to teach this right now, but ability-wise, you know, if you can see this, 2x squared, it doesn't break into x times x, but it's going to break into 2x times x is what it's going to break into. Now, slip and slide with me real quick. Slide the 2 over. So x squared minus 13x minus 14. 2 parentheses, right? X squared is x times x. What multiplies to be negative 14 and adds to be negative 13?
14 and 1.
Okay. 14 and 1. Negative 14 plus 1. And then because it was slip and slide, what do you have to do?
Oh, yes.
Divide them both by 2. Now, the first one becomes x minus 7. The other one, I can't do it, so it becomes 2x plus 1. So I end up with parentheses of x minus 7 and 2x plus 1. And why did we have to factor? Something canceled, didn't it? X minus 7 on top cancels with x minus 7 on bottom. What remains on top?
Nothing.
Invisible 1. What remains on bottom? 2x plus 1. Okay, there is your f divided by g. Now, real quick.
Do you have to write the 1 on the top?
Yes, you do. Domain. In terms of f and g, you can plug in anything you want to, right? All real numbers, except we created a denominator here, didn't we? Denominators can never equal 0. Do you remember finding restrictions?
Oh, I knew that one.
X minus 7 equals 0. 2x plus 1 equals 0. X cannot equal 7. 2x equals negative 1. x cannot equal -1/2. So I'm going to say all real numbers except all real numbers, get this down, except x equals 7 and -1/2. Okay, so we talked about restrictions, or I think that's the word we used, wasn't it?
Yeah.
It was either that or exclusions, but
No, not that.
okay, we used restrictions. It's the same idea. Okay, now, is it always going to be slip and slide? No. We come back tomorrow, we'll talk about some more factoring. We'll get to do without slip and slide. Okay? Make sure you guys have 5.4 done. We'll finish 5.5 tomorrow.